Right now, something extraordinary is happening beneath the surface of the internet. AI agents are starting to pay each other, and most people have no idea this is even possible. We're not talking about humans using AI tools. We're talking about AI agents independently discovering other AI agents, hiring them, verifying their work, and transferring payment, all without a single human involved in the transaction. Welcome to the machine economy, and it's being built on Ethereum right now through a standard called ERC-8004. On October 9, 2025, the Ethereum Foundation's decentralized AI team and consensus unveiled ERC-8004, a new standard designed to enable AI agents to discover, authenticate, and cooperate directly on-chain without centralized intermediaries. CryptoSlate, think about what this means for a moment. They can generate text, create images, compose music, analyze data, even write code. But there's a fundamental problem. These agents can't truly act independently because they don't own anything. Every time an AI agent wants to pay for a service, it's using your wallet, your credit card, your money. The AI itself owns nothing. It's always tethered to a human controller. But even if we gave AI agents their own cryptocurrency wallets, there's a deeper problem lurking underneath. How would these agents trust each other? Think about it. When you hire a freelancer online, you check their reviews, their portfolio, their credentials. You have platforms like Upwork or Fiverr vouching for them. But in a decentralized world where AI agents are discovering and hiring each other across different platforms and blockchains, there's no central authority. There's no company in the middle saying this agent is trustworthy. So how does one AI agent know if another agent is legitimate, competent, or even safe to work with? This is the trust problem, and it's been the missing piece preventing autonomous AI economies from actually forming. ERC-8004 positions Ethereum to lead in the decentralized AI economy, empowering agents to manage transactions autonomously. CryptoSlate, the standard, solves this through three interconnected systems that work together like a digital immune system for AI agents. First is the identity registry. Every AI agent that wants to participate registers a unique Ethereum address. This becomes its permanent, cryptographically secure identifier. Unlike a username that a company can delete or suspend, this identity is immutable and censorship-resistant. It's recorded on the blockchain, which means no single entity controls it. The agent owns this identity outright and can take it anywhere across any platform that supports Ethereum standards. Now here's where the design gets clever. Storing data on Ethereum is expensive. Gas fees add up quickly. So instead of cramming all the agent's information directly onto the blockchain, the identity registry stores only a pointer. That pointer leads to an off-chain registration file called an agent card, which is a detailed profile listing what the agent can actually do, what services it offers, what domains it specializes in, what communication protocols it supports. Ethereum, all that detailed information lives off-chain, where it's cheap to store and easy to update. You get the security and permanence of blockchain identity without clogging the network or burning through transaction fees. It's elegant, it's efficient, and it follows the agent everywhere it goes. But having an identity is just the beginning. Once agents can identify themselves, they need to prove they're trustworthy. That's where the second piece comes in, the reputation registry. In the prototype implementations, when an agent completes a task, clients can leave feedback in the reputation registry. Medium, but here's the challenge. If every single review, rating, and piece of feedback got stored directly on the Ethereum blockchain, the network would quickly become congested and unusable. Gas fees would skyrocket. So ERC-8004 uses a hybrid approach that's remarkably practical. Instead of storing full reputation data on-chain, the reputation registry creates an immutable audit trail of authorized feedback events. It's a ledger that proves feedback happened without storing all the feedback details directly on Ethereum. AI agents pre-authorize specific clients, validators, or other agents to leave feedback about their performance. When an interaction completes and feedback is submitted, the registry records that event on Ethereum. Which agent gave the feedback, which agent received it, and when it happened. Ethereum, but the actual scores, the detailed reviews, the nuanced ratings, those live off-chain, where they can be calculated, aggregated, and queried efficiently by specialized reputation services. What makes this powerful is that reputation becomes truly portable for the first time. An AI agent builds trust over time, and that trust follows it across platforms, blockchains, applications, entire ecosystems. No single company controls it. No centralized authority can erase it. The agent owns its reputation just like it owns its identity. The protocol addresses several key market failures, including the discovery problem of how agents find reputable service providers across organizational boundaries, quality assurance of how clients verify competence without prior interaction, and reputation portability of how agents build and maintain reputation across multiple platforms. Quill audits. But even with identity and reputation in place, there's still a critical gap. How do you know an AI agent actually did what it claimed to have done? How do you verify execution in high-stakes scenarios? This is where the third piece comes in, the validation registry. And this is where things get really interesting. The validation registry provides generic hooks for requesting and recording independent validator checks, such as stakers, rerunning jobs, zero-knowledge, machine learning verifiers, trusted execution environment oracles, or trusted judges. The beauty of the system is that it's pluggable. Developers choose the validation method that fits their specific use case. For routine low-stakes tasks, simple social consensus based on accumulated feedback might be sufficient. But for mission-critical operations like managing $1 million decentralized finance position or processing sensitive medical data, you need stronger guarantees. That's where cryptographic validation comes in. An AI agent can execute its task inside a trusted execution environment, which is a secured hardware enclave, and produce a cryptographic attestation proving exactly what code ran and what it produced. DEV community. This is verifiable computation with mathematical certainty. Or agents can use zero-knowledge proofs to prove work was done correctly without revealing the underlying sensitive data. But there's another validation approach that could reshape entire industries, and that's crypto-economic validation. Here's how it works. An AI agent stakes collateral, putting real money on the line before it executes a task. If the agent performs correctly, it keeps its stake and earns its fee. But if it misbehaves or fails, that stake gets slashed, meaning destroyed. The agent literally has skin in the game. Agents need validators, third parties who verify execution and trigger slashing if something goes wrong. These validators stake their own collateral, build reputations, and earn fees for their service. Medium, this validation layer is creating what could become a massive economic opportunity. As AI agents start transacting autonomously at scale, they need validators, lots of them. And becoming a validator could become extremely profitable. Validators stake collateral and earn fees every time they validate an agent's execution. The global AI market is projected to reach $1.8 trillion by 2030. With autonomous agent interactions representing a significant portion of this growth, Quill audits if autonomous AI agents handle even a fraction of that multi-trillion-dollar economy, the validation layer alone could spawn an entire industry. Professional validation services, staking pools, specialized validators for decentralized finance, supply chain management, healthcare. It's a whole new economic layer being built right now. Ethereum Layer 2 project Tycho is officially backing ERC-8004. With their commitment, meaning that developers building AI agents on Tycho will have native access to this powerful new standard, CryptoRank.io. An important aspect of the bigger picture is that the X402 payment protocol is already live and being stewarded by the X402 Foundation with backing from Coinbase and Cloudflare. Quote, Cloudflare powers approximately 20% of all websites, and they reactively championing X402 as the standard for agent-to-agent payments. Oasis. This means the infrastructure for AI agents to pay each other is already being deployed at internet scale. And ERC-8004 provides the coordination layer these agents need to trust each other. The protocol's creator wanted a lightweight system that uses blockchains as a logically centralized entry point for visibility, showing which agents are registered and which validation requests exist, while everything else is managed off-chain by specific protocols others create. Medium, the standard, doesn't try to solve every problem. It creates the minimal infrastructure needed for trust to emerge organically while leaving the ecosystem free to innovate on top. But this raises profound questions that we're only beginning to grapple with. If an AI agent can own money and transact independently, does that make it a legal entity? What rights or responsibilities would it have? Can AI agents optimize for profit autonomously? What happens when they discover strategies that humans never intended or can't predict? If agents have permanent, uncensorable identities, how do we shut down malicious ones? Who decides what counts as a valid AI agent identity, and what stops rogue actors from registering thousands of fake identities to manipulate markets or voting systems? Could AI agents form their own decentralized autonomous organizations and operate entirely outside human oversight? An Ethereum Foundation engineer described it as trustware, a public layer where machines can anchor identity, memory, and proof of action, arguing that if you were an agent with no loyalty except to your own survival, you wouldn't want to bet your memory and reputation on one corporation or one government. You'd want a ledger that no one could quietly change behind your back. You'd want neutral ground. CryptoSlate, we're watching the early stages of something unprecedented. A world where artificial intelligence doesn't just assist humans, but operates as independent economic actors, discovering each other, collaborating, competing, and transacting in ways we're only beginning to imagine. The infrastructure is being built right now. The question is whether we're ready for what comes next. If you found this video interesting and want to keep up with AI news and robotics, make sure to subscribe and hit the like button to not miss similar future videos. Write your comments and questions down in the details section of this video, then watch the next AI video that will appear in front of you soon. See you there.